Welcome to Module 2. So this is your task for 2.1. For number 1, it says complete the following table of values for y equals x squared. Then identify the features of this parent function. So let's go ahead and make the table. What we're going to do is we're going to plug these x values into this function. So negative 3 squared is 9. Make sure that when you plug negatives into your calculator, you put parentheses around them. It should be negative 3 in parentheses. If you put it in like this, it will probably give you negative 9, which is incorrect. So make sure that you use parentheses. So then we're going to do negative 2 squared, which will give you 4. Negative 1 squared, 1. 0 squared, 0. All right. The way I got those is I just simply squared the numbers because that is what the function does. All right. Then we get 1 squared again. We get 1, 2 squared, 4, and 3 squared, 9. And we can go ahead and plug these in here. So we got 0, 0, 1, 1, 2, 1, 2, 3, 4, and 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so that is the half of the graph. Then we can plot 1, negative 1, negative 2, 4, and negative 3, 9. So we get what we call a parabola. All right, you could say parabola, quadratic function. All right. So now let's go ahead and fill out this information. So for the domain, now if you recall, the domain is the input values. Now, is there any number you could not plug into this function? No, you could plug any x value into this function. You could go to negative x values, positive x values. You could plug in anything. So the answer should be negative infinity to positive infinity. Then they ask for the range, all right? So if we're looking at the range, those are the x values or the output. And if we're looking at this graph, all of our output values are above 0, all right? So our output here would be 0 to infinity. Now notice that I used a close bracket because the y value actually does equal 0 at one point. That's this part here. So it would be close bracket 0 to positive infinity. Then they ask for the intervals of increase. So let's take a look. When is this function increasing? Okay. Well, if we look, this function is going to have positive, essentially a positive rate of change for any value greater than 0. So we would say 0 to infinity. Now, when does this function have a negative rate of change? Well, we can see that these rates of change are negative. So we would say negative infinity to 0. Next, it asks for the minimum or maximum. So if we're looking at this graph, our minimum value happens right here, right? That's when the graph is at its lowest point. That's going to be at 0, 0. And then it says we have a special name for the minimum/maximum point. This, for parabolas, this is called the vertex, all right? So if I ever ask for the vertex, I'm asking for this point here. That would be the minimum or the maximum value. Then the last one, it says name the folding line of a parabola. So what do they mean by folding line? Okay, they mean the line that kind of splits the parabola exactly in half. It's a mirror image of itself, right? So this is called the axis of symmetry. And it's always going to be written as x equals, and then the x value of your vertex. So x equals 0, and that makes sense because that dashed line I just drew would be x equals 0. All right. So let's kind of talk about a parabola here. So this is called the vertex form of a parabola, and we're going to be using this a lot. And we'll be doing it a lot. So if you don't get it this first time I explain it, don't worry. You're going to be doing tons of examples with it. So first thing I want to point out is this h and k. All right. The vertex is always h, comma k. So that means since this is minus h, you have to flip the sign in order to get the vertex. All right. So you flip the sign of the h, and that gives you your x value of the vertex. And then the a here is going to be associated with a vertical stretch or compression. So if we look down here, we can see that h and k change where the vertex is. All right. And k moves it up and down, h moves it right to left. So we can see here by changing k, it moves it up and down. Changing h moves it right and left. Now, a can do a couple of things. If a is negative, it's going to open downward. So if your a value, if that number out in front is negative, it's going to open down like a frown. If it's positive, it's going to open up like a cup. Now, a can also do a couple other things. If the absolute value of it is greater than 1, so some examples of this would be like 2 or negative 2, right? The absolute value of both of these are bigger than 1. That means that you're going to get what's called a stretch. All right, that's what this, the blue here is the parent function, and the red is the transformed function. So blue is what we had to begin with. We changed it to greater than 1, and we can see that it got stretched. Now, if we change the absolute value to less than 1, some examples of this would be 0.5 or negative 0.5, right? The absolute values of both of these are less than 1. We get a compression, right? You see how it kind of gets pushed down. Imagine you pushing down on that parabola. It gets compressed. All right, so next it says, describe the transformations that would be needed to move the parent function y equals x squared to the given function. Identify the vertex, direction in which the parabola opens, equation of the axis of symmetry, domain, and the range. Okay, so let's go ahead. If we're looking at this guy here, right, keep in mind we're using the a times x minus h squared plus k, right? So think about which each one does. If you notice here, a is just 1, so a didn't do anything. A is just regular, but we do have a different h and k. So remember, like I said, to find the vertex, you switch the sign of this value and you keep the sign of this value. So it would be positive 6, positive 3, because the 6 has to change the sign. The x value switches the sign. And that's really the only transformation that occurs here, would be the sign change. So you would say that the transformation is going to be right 6 and up 3. So think about it this way. Our vertex started off here. Then we have to go to 6, 3. We went 6 to the right, up 3. Okay, so that's the only transformation that occurred, and this guy would look something like that. All right, now they want to know what direction it opens. Well, it opens up. Then they ask for the axis of symmetry. So to reiterate, the axis of symmetry is always x equals, and then the x value of your vertex. So it'd be x equals 6. Next, they ask for the domain. The domain for all parabolas should be negative infinity to positive infinity. That's not going to change because you can plug in any value into a parabola. Then they ask for the range. So now we have to look at our y values. They're a little bit different here, right? Our y values are actually going to start here at 3, and they open up, right? So our range is going to be 3 to positive infinity. So that's how you would do the first one. All right, next one. They ask for the transformations. So first, let's get our vertex. Let's actually get our vertex here. So we've got negative 2, comma, negative 5. So remember, we have to switch the sign of our x value. So since it was positive 2, it is now negative 2 for our vertex. And if we were to plot this vertex, we go negative 2, negative 5. All right, so for that transformation, we would say 2 left, 5 down. But now look, the a has changed. Instead of it just being a 1, it's a negative 1. So if we look back here, we know that when we have a negative value of a, we reflect over the x-axis. It flips down. So now it's going to be down like a frown. So if we were to graph this guy, it would look something like this. So our direction is going to be that it opens down. The axis of symmetry, x equals negative 2, right? We're going to use our x value. Our domain, negative infinity to positive infinity. Now let's think of our range here. Our range is different. Our range value is going to be negative infinity, and then it's going to stop right here. Okay? So it's going to be negative infinity to negative 5. And notice how there are no y values above negative 5. All right. Next one. Oh, actually, I forgot to write the other transformation. I apologize. So we said it went 2 down, 2 left, 5 down. We should always say that we should also say that it reflects over x axis, right? It reflects. All right. So now we've got this one. Again, first, let's find the vertex. That really should be the first thing you always do. Our vertex here is 1, 3. Again, you switch the sign. The y value keeps its sign. 1, 3. So let's kind of just do a rough graph of that. We get 1 plus 1, up 3, and that is going to be our vertex. Okay. Then they want to know what direction it opens. So if we look here at our A, I'll just highlight. Our A value is negative. So that tells you that we are going to open down, like a frown. Then there's another thing with the A. The A value is now, the absolute value is less than 1. So we go up here. We know that when our A value is less than 1, we get what's called a compression. It's going to kind of become a little bit wider looking. So our graph would look something like this. Do you see how it's wider? And it opens down. So let's talk about all of these transformations. We went 1 to the right. Oh my goodness. 3 up. We reflected over, x-axis. And we had a compression. Then they said, what is the axis of symmetry? It's just going to be x equals 1. That's that guy there. What's our domain? Negative infinity to positive infinity. And then if we're looking at our y values, right, our y values are all going to be lower than this guy here. Okay, that's a maximum. So we're going to start at negative infinity, and our highest value is going to be 3. Notice how the range always includes some portion of the vertex. You have to pay attention to whether it opens up or down, and that tells you what infinity it's going to be. So if it opens up, it's going to go to positive infinity. If it opens down, it's going to start at negative infinity and then end at your point. It should be a closed bracket. All right. Next one, let me erase this terrible parabola I drew. All right. So first, let's find our vertex. 3, -7. Hopefully by now, you're figuring out at least how you find the vertex, okay? Then they want to know what direction we open up in. So if we're looking here, our A is positive, so we're going to open up. So let's go ahead, kind of do a rough graph, 3, -7, and we're going to open up. Then we notice that our A is bigger, the absolute value of A is bigger than 1. So we know that when the absolute value of A is bigger than 1, we get a stretch. So for our transformations, we're going to say 3 to the right, 7 down, and a stretch. So our graph is going to look something like this. Notice how it is stretched. Our axis of symmetry is going to be right there, x equals 3. Excuse me. And our domain, same thing, negative infinity to positive infinity. And now our range. Our range is going to start here and go up. So we're going to start at -7 and go to positive infinity, right? That goes on forever. All right. I did want to do at least one question from the ready. So let's go ahead here. I'm going to do number 1. So it says find the y-intercept b of each line using slope-intercept form y equals mx plus b. To do this, substitute in the slope for m and the given points for x and y, and then solve for b. So what are they asking you to do? Well, we all know y equals mx plus b, okay? And this equation right now says 4 unknowns. We don't know x or y, we don't know m, and we don't know b. But they did give us 3 pieces of information. They gave us m, which is that. They gave us x, which is that guy. Then they gave us b, which is this guy. Or I'm sorry, not b, goodness gracious. They gave us y. We're trying to find v. So we're going to go ahead and plug in all of these values. So we know that our y is -6, our m is 3, our x is 5, and we don't know what our b is. That's what we're trying to find. So let's go ahead and we're going to solve for b. So we've got -6 equals 15 plus b. All right. Then you're going to do -15, -15. You get b equals -21. All right. So that would be your answer for A. And if you wanted to give the full equation, you would say like y equals 3x minus 21.